go. Yeah, I'm going to do some stuff on some triangle things today. Talk about that converse of Pythagorean theorem that we were looking at. Let's do that here. All right, let's take a look at that. So we were talking about if we had a squared plus b squared equals c squared, then did that guarantee us a right triangle? All right, that's what we wanted to know. So I had you go take a look at this one GeoGebra document. All right, and I'm going to go see if I can get that still. All right, let's see if we can find that. I think I'm going to have to do something different. There we go. And here. And this is the one I want, right here. So what I did is I filled this one in for you. And I don't know if yours worked very well, because when I was doing it, I found a couple things I thought worked but didn't. But this has been kind of a bugger for us as it is. So anyway, hopefully, if you take a look at this, maybe you'll see some sort of a relationship between the sum, which is the E and the F columns, the two sides, 1 and 2 squared. Adding those up, that's the sum in the G column. H column is the hypotenuse squared, which is always our longest side. All right, so there's a relationship in each one of these triangles comparing the sum and the hypotenuse squared. So you should just pause this and take a look at this for a few minutes and see if you can come up with it, because this is what we would do normally. Try it. Okay. So hopefully you did. I'm hoping that you did. If you look at the G column and the H column for the acute triangle, there's one thing that kind of jumps out, but it probably wouldn't be something that you would normally maybe see. But the G column is larger. In every single case, the G is larger than the H. In the right triangle, they're identical almost, like 96.64, 96.63, really close. Same with 70s and the 70s and those two 93s. In the obtuse triangle, we notice it's just the reverse of what we had with the acute, okay? That the H column is larger than the G column. So this is what's true about this particular idea of a squared plus b squared equals c squared. So if a squared plus b squared is less than c squared, then we're going to get what we call an obtuse triangle. All right? That's what's going to happen, because that's what that little spreadsheet showed us. Right? A squared plus b squared is less than c squared. We're getting an obtuse triangle. A squared plus b squared is equal to c squared. Then we're going to get a right triangle. Alright, so I got to not tap too hard because this thing just makes so much noise. There we go. A squared plus b squared is greater than c squared. Then we're going to get an acute triangle. And again, that is what the little spreadsheet told us. Alright, so there we go. So this tells us what kind of a triangle we're going to get given any three types of side lengths, according to that spreadsheet. And what we did, we moved the triangles around. You should have found some things. So let me scoot this up a little bit. Let's say that we have three side lengths. Can we tell what kind of triangle is this? Okay, type of triangle. What type of triangle is it? Well, let's try one out. So let's go with 3 and 8 and 10. All right, so it's an interesting little triangle here. 3, 8, and 10. So we want to take the two short sides, and we're going to square them, and the long side, and we're going to square it. And then we're going to see where all that falls out. So we get 9, and we get 64, and we get 100, and we see that this is 73, and this is 100. So since this side is bigger, that makes this an obtuse triangle. The c squared is bigger, so it's obtuse. We know that automatically. All right, a squared plus b squared is less, the c squared is larger. That's an obtuse triangle. Let's scoot on up here. Let's try a different one. So let's go with a 5, 6, and 8. Let's try this one. 5, 6, and 8. So we get 25. That's my small one, plus 36 and 64. So that's 5 squared, 6 squared, 8 squared. Let's see. So 5 and 36, that adds up to 61. This is 64. So how about that? We get another obtuse triangle because this is larger, so it's going to be obtuse. All right. Okay. Let's try another one here. We'll scoot this up. You thought that was going to be something different, didn't you? How about this one? 6, 8, and 10. Let's try these out. So we're going to go 36 plus a 64 and a 100. So this is 6 squared, 8 squared, 10 squared. Remember, it's always the two short ones. You always want to take the two short sides and square them and add them up. All right, so let's see. We get 100 here. I get 100 here. So how about that? This is a right triangle. Okay, right triangle. So we did 3 examples. We got 2 obtuses and 1 right. Okay. Now the other thing I wanted you to take a look at was in here, and it was on my website. Okay. And it's called Triangle Inequality. So let me go, well, let's see if I can go back. It doesn't look like I can. But on the website, if you go to Unit 8, right, and Triangle Inequality, I'm pretty sure is what it's called. It might be, yeah, I think it's what it is, Triangle Inequality. This is what we're going to get, all right? And if I slide this around, and you should be sliding it to, I know you're going to watch the video, but you should pause the video and go slide this around, and slide this around, and slide this around. Something's going to jump out at you at a certain point. All right, and that's what I want you to figure out. What is going to happen here? Okay, what is going to happen? So play around with that. See what you get. All right, so hopefully kind of played around with that a little bit. And you noticed something. Okay, I noticed that if I make this a different size, at some point, I don't get a triangle anymore. Now, that's pretty much 0. So let me make this just go like this. Now I have a triangle. See, I don't have a triangle here. Okay? There's certain side lengths that just aren't giving me a triangle. Now, how do I know what those are? Well, what we could do, if we were in the classroom, of course, we do this every year, is we take a piece of spaghetti and we break it. So if you want to take a piece of spaghetti and break it in 2 spots and try to make a triangle out of it, you'll probably get one, because most people are going to break it in good spots. But it's possible that if you take that piece of spaghetti and you break it just right, that you won't get a triangle, because these 2 pieces will be too small, right? So if this is like 20, okay, and this is like 10, but this is only 7, well, we're not going to get a triangle there. This 7 is going to fold down here, this 10 is going to fold down here, and we're going to have a gap there. And that's what this thing is trying to show you. That if we have this, so this right here, I got a 17.1, right? And a 10.8. So if I make this a little bit bigger, all right, to 6.8. Here, let me make this just a nicer little number there. How about 11? There we go. So right now I have 17.8, so I get a triangle. But watch what happens if I make this orange just a little bit smaller. Now I jumped that green down too much. Oh, I messed this up big time. Let's see if I can get this to be about 17, like where I had it. I'll get this green one to be about 15 where I had it. Or 11 will work. There we go. So this one here right now, I got 7 and 11 is 18. But as soon as I start making it smaller, I still got a triangle, right? 6, 11, 17.2. But as soon as I hit 6, I don't have a triangle anymore. 6 and 11 add up to 17. It's just a hair bit smaller than 17.1. See? And that's what does it for me. So those sides, these two sides, got to add up to that larger one. So to form a triangle, we call this the triangle inequality theorem, by the way. But I'm not too interested in that you know the name. I'm more interested in that you actually know how to do it. To form a triangle, these two short sides, so I'm going to say the sum of the, let me erase this junk that's in here, of the two, okay, short sides has to be greater, must be greater than the largest side. So if we were going to put letters on that, all right, then what we would do is we would say that, why isn't this not moving up? Oops, got the wrong thing. Okay, we would say that the A plus the B has to be greater than the C. All right, where A and the B are the two short sides. All right, so this is an important idea, right, that we're getting here. That to form a triangle, the sum of the two short sides must be greater than the largest side. All right, so let's take a look at some problems with this. So I'm going to say we're going out to the old woodshed and we're going to pick out some side lengths and see if we can get triangles. So do these form triangles? Do these form triangles? Let's find out. All right, so let's say I go out and I find one that's 12 inches. I got one that's 10 inches, and I got one that's 28 inches, and I want to know, hey, am I going to get a triangle out of that? Because I'm building something and I need a triangular brace. All right, so I'm going to take my two short sides, right? I'm not squaring them, not the Pythagorean theorem stuff. It's just straight up adding. 22, 28. Nope. Remember, this sum has to be larger, okay? And it's not. So it does not form a triangle. All right? No triangle. No. Well, okay, I'm going to stick with my 12 and 10, see if I can find another one. Let's see, I got 12, 10. I pull out one. Let's say I got a 20. All right, is that going to work for me? Well, let's take my two short sides. All right, 12 and 10. I already had that up. I know it's 22. This one's 20. So, yeah, I'm going to get a triangle here. You bet. All right, so that one will work. Okay. Well, let's continue with this a little bit more. So let's say I still have that 12 and 10, right? What side lengths will make a triangle, and how do I know? Well, I know this, that I have 12 and I have 10. All right. So I know that a 1 foot one won't work because 1 and 10 give me 11. That doesn't work. 10 and 2, that's just going to fold right down on top of that 12, right? So I have 12 here, and I got 10 that goes across to there, and then I got this little 2 there. It's not going to angle up at all. It's going to add up to the same thing, so that doesn't work. Right? So then, what I want to do is, well, if 2 doesn't work, would anything larger than 2? Yeah, so then that means any side length that I have that is larger than 2 is going to be okay. But is there a limit? Could I have 100? Well, obviously not, because 12 and 10 are the 2 short ones. And they didn't come close to adding to 100, right? I can figure that out. That's not going to work. What about 30? Would 30 work, right? So I look at this and I go, no, again, 12 and 10, that adds up to 22. Well, 22 isn't going to work, but anything less than 22 would work. All right, so there is my triangle inequality idea, that any side in that length will form a triangle. Okay? And it's easy to get that because all I did was subtract these, right, and add these. The add goes there and the subtract goes there, and that worked. All right, cool. One more interesting triangle thing before we move on here. So the other one's called angle and sides, all right? And I'm going to slide this, okay? And that goes there, and that goes there. You might say, well, what's the big deal about that? Well, let's come back to this again, okay? It's pretty easy to see that angle A is the largest angle. And if we don't believe it, let's go ahead and measure them. All right, there's that one. And there's that one. And there's that one. So it's easy to see that A is the largest angle. If I slide this, I see that angle A goes to the side that's opposite. It's directly across from it. Side A. And side A is larger than the other 3 sides. I don't even have to measure them. I can see that it is. All right. Now I'm going to go with angle B, which is the smallest angle that I have, goes to the smallest side, which is side B. I can see that B is obviously the smallest side. Finally, C goes to that. And it doesn't really matter what triangle we have, that largest side is always going to go to that largest angle. So, the largest side in a triangle, okay, oh my goodness, in a triangle, I don't want to write in this, sorry folks, we don't want that. In a triangle, the largest side is opposite the largest angle. So the largest side is opposite the largest angle. There we go. The largest angle. And the smallest side is opposite the smallest angle. Okay? So if I have a triangle like this, all right, this angle is my largest angle, then this is going to be my largest side. Okay? If I have this one being my smallest angle, small, then this is going to be my smallest side. Okay? Because it's opposite it. All right? That's what that says. In a triangle, the largest side is always opposite the largest angle. Kind of makes sense if you think about it. All right, so it's nothing that's really that earth-shattering there. Hoofties. Okay, last thing we're going to do is talk about the Great Pyramid of Warren. Okay, and you may have seen it and may not. It's kind of tucked away. It's kind of hard to see, but it's a pretty darn big pyramid. All right, And the crazy thing is that it's a square pyramid on the bottom. Alright, so it looks like that. Okay, so it's square on the bottom. And it happens to be about 200 units that way and 180 units that way. So it's a pretty dang good sized pyramid, but it's kind of tucked away, behind a little bit of hills and some trees, and it's kind of hard to see, but it's there. Okay. What I've always been kind of interested in is what the height of that darn triangle is. All right, so this height here, I'm kind of interested in. All right, and what I'm going to do is complete this triangle by going like that. So I want to find the height of it, so I'm going to take that triangle there. I want to kind of bust it out. I want to clean this up first because I didn't do a very good job there. So let me try this again. There we go. And I know that this distance, since this is a square, is going to be half of that 200. All right, there's the h that I'm trying to find. But I don't know any other side, and so I can't use a squared plus b squared equals c squared, unless, of course, I got another side someplace. But I don't know that side. It's this one right here. So I'm going to look at this other triangle here. So I'm going to go back to this color. I think I'm going to pick this little goldie. I don't know what that's going to look like, but let's take a look at it. Oh, look at that. Nice stuff. So I'm going to take that triangle, pull it out. Okay. This side is right here. And again, we have half, so that's 100. Okay, and that's not h, that's just this same value that I'm trying to figure out. So we'll call this c, and we'll call this c. So now we do have enough information to do this. We can go a squared plus b squared equals c squared. Alright, so I'm going to scoot this up, scooch, scooch, scooch. We're going to go 100 squared plus b squared equals 180 squared. Okay, I want to clean up all my mess here that I have. I know 100 squared is this because we've done that. I don't know what b squared is, and 180 squared, so I have to take my calculator and figure that out. 180 squared. Let me get my calculator out here and do some 180 squared. So that's 3 to 400. All right, you probably already played around with that. B squared is going to subtract that, right? So we get 22,400. You guys are awesome at your algebra because you had good algebra teachers. Okay, here we go. B then is going to be the square root of that thing. So I'm going to go ahead and do that. 22400, and I need to square root it right there, and I get 149.6. All right, so now that I know that this is 149.6, I can go back to this triangle, okay, and do a squared plus b squared equals c squared on it. Man, this is a lot of work to come up with this height of this pyramid of Warren, but someday when you're out in Warren, you can look around for it and see if you can see it. You can say, hey, I know how tall that is. All right, so here we go. So I think I'm going to have to do some lassoing here. Move that guy over there a little bit. There we go. Of course, it took that with it. That's not a good thing. There we go. 100 went here. Okay, so I'm ready to go to work. So let's see, we already know what this 100 squared is because we did it already. Okay, and lucky, we really already know what 149.6 repeating squared is. That's 22,400 because we did it right there. So really, this isn't a whole lot of extra work. We just got to do something like this by subtracting and then taking the square root of that number. So let me try that out. See if you guys can get it faster. You probably did. So we get 111.4. So there is the height of my pyramid of Warren. Okay. So on your assignment, you're going to have some problems like that, where it's going to have you figure out some pyramids. Some of them are going to be just one step Pythagorean theorems. Some are going to be like this one, are going to be two. All right. You're also going to have a Google Classroom problem on there, and that's pretty much it. So I made this document so you can write on it, but again, I'm encouraging people to take pictures and attach them. Draw some pictures because it's geometry, so you should be drawing some pictures to help you out. Yeah. Hey, any questions? Let me know. Be happy to meet with you. Want to see you. Want to help you. All right. And the rest of the time, have a great day.